Alrighty, gang, let's do it. Today's second video of the week, we're on section 12.5. Previous section was on tangents and segments. Today we're going to talk about chords and segments. So remember, a chord is a segment who has its endpoints on the circle. Okay, so our first theorem, it's going to be a pretty short day. There's just a couple of pretty basic theorems that we need to learn how to apply. It says in the same circle or in two congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Okay, so in purple, I've got two chords here, BA and CD, and I say that they are congruent. What that means is their corresponding minor arcs, so less than 180, then have to be congruent. So that is the case if and only if segment AB is congruent to segment CD. Okay, so it goes both ways. If you have the congruent chords, the minor arcs are congruent. If you have congruent minor arcs, then the chords are congruent. Okay, so first example, we're dealing with two different circles here. So it says circle A and circle D are congruent, so they are congruent circles. I know BC is congruent to EF, so I've got these chords congruent, BC and EF. The measure of EF in purple here is 125. The minor arc for the other congruent one would be BC, so I know that's got to be the same. I'm getting ahead of myself, but it says find the measure of arc BC. The measure of arc BC by that last theorem is just equal to 125 degrees. It's that simple. Okay, so like if I said this was 2x plus 5 and said solve for x instead, you would say 2x plus 5 equals 125. Go through and solve. Okay, so then just two more theorems here. So theorem 10.14 says if one chord is a perpendicular bisector of another chord, okay, so if this is a perpendicular bisector, notice I've got the 90 and I've got it bisecting that, giving me two congruent pieces. If that is the case, then the first chord, I'm going to change up the color of that first one we talked about, is a diameter. So if QS is a perpendicular bisector of TR, then segment QS has to be a diameter. Okay, theorem 10.5, kind of similar here. It says if a diameter of a circle is perpendicular, okay, so diameter right there, and it is perpendicular to another chord in purple, right there, FD, then the diameter bisects the chord and its arc. So it's going to bisect this chord, and it's also going to bisect, I'm going to do it in yellow, the minor arc. So I've got HD and HF are congruent. We wrote that. And also, we can say that that chord is bisected. So chord DG is congruent to chord. No, not chord. I'm sorry. Arc. Arc DG and arc GF. Okay, you could switch up the order there. Arc GD is congruent to arc FG. Okay, as long as you just use two letters, I know it's that minor arc you're talking about. Okay, so example 3 says use the diagram of E to find the length of segment BD. Tell what theorem you use. We won't tell the theorem, but let's take a look at this. So I've got, looking at this one, I know that this right here, AC, is a diameter. And since I know that's a diameter, I know it bisects the chord it's intersecting there. Okay, so since that's a diameter and it bisects, I want to find BD, which is this entire length. So all you have to do is take 2 times 6, which is 12. Okay, so really I guess we should say 12 units. All right, theorem 10.6 says in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. I want you guys to add this in here because we haven't talked about this in a while. When we talk about two lines being a certain distance from a point, it's always got to be the perpendicular distance because that is the shortest possible distance. That's taking us back to like chapter 3. Okay, so this is telling me that the two chords AB and CD, are congruent if and only if EF and EG are the same. EF is equal to EG. Now the theorem says equal, so notice I didn't put the little segment sign above, but I mean, congruence in segments and the measure of the segments, if we remember, from our proofs. Okay, so it means the same thing. So example 4 here is in the diagram of circle F, AB is equal to CD. So I've got AB and CD are the same. They're both 12. I want you to find EF. So there's EF. I'll do that in red. Now, based on that last theorem, what that's telling me is I know that these two perpendicular distances that I just drew in red have to be equal. So set 3x equal to 7x minus 8. I can subtract 7x or move 3x over, however you want. You guys don't like negatives, but if I move 7x over, I get negative 4x is equal to negative 8. This gives me x is equal to 2. You can always go back and check. 3 times 2 is 6. 7 times 4 is 4. 7 times 4 is 4. 7 times 2 is 14. Can't talk today. 14 minus 8 is 6. So it does check out. All right. Short and sweet. There's your homework. Give those problems some tries before you guys dive in right to the assessment for the week. We got one more video to go.